Smart assistive device for speech impaired. Using silent sound technology. Abstract. One of the beautiful creation of God is human beings who have been fortunate to have senses like vision and speech. But some humans are unfortunate to have this blessing. Speech-impaired people are greatly affected as they cannot communicate effectively as in the case of normal people by verbal means. Here speech-impaired people communicate using sign language to communicate with others. But others who does not have the prior knowledge of what sign language is, find it very tough to understand what speech-impaired person is trying to express. Smart assistive device can help speech-impaired people to effectively communicate with others. This device can help people who have undergone surgery such as laryngectomy, a surgical removal of larynx which is usually done when person suffers from a critical accident or throat cancer. Using the smart assistive device, it decodes the movement of lips and then convert it to text and audio. The listener on the other end can be either a normal person or a hearing impaired person. Here normal person can hear the audio of the spoken word and hearing impaired person can see the word displayed on the screen. Introduction. Communication is an important characteristic of human behavior and embodies human beings' ability to convey information, feelings, opinions to others. The main aspect of communication is that the receiver has to understand what the sender is trying to communicate. In the case of speech-impaired person, they communicate with others using sign language, a visual means of communicating using hand signals, gestures, and facial expressions. Here the person on the other end find it very difficult to understand what the other person is saying if he or she does not have the prior knowledge of sign language. This project is proposed to ease the communication between speech-impaired person and normal person. In this project, speech-impaired person's lip movements are analyzed and compared with pre-prepared database and releases output such as text and voice. 2. Existing system. In the existing system, it involves use of ultrasound probe, camera, and a silent vocoder. Here image of vocal cords are taken from ultrasound probe and along with this the movement of lips are captured using camera. The captured images of lip and tongue movement are then given to lip reader. Lip reader then compares the input image with pre-stored images and if a match is found it generates a visual speech signal. This visual speech signal is then given to a silent vocoder. The silent vocoder consists of an HMM-based visuophonetic decoder, audio-visual selection unit, concatenation of the selected units, HNM-based prosodic adaptation. Then the silent vocoder converts the visual speech into spoken words. 3. Hardware requirements. Raspberry Pi 4 Model B. It comes with a gigabit Ethernet, along with the onboard wireless networking and Bluetooth. It has also upgraded its USB capacity, along with 2 USB 2 ports, 2 USB 3. 2. Raspberry Pi 5 MP camera. The Raspberry Pi camera board plugs directly into the CSI connector on the Raspberry Pi. It is able to deliver a crystal clear 5 MP resolution image, or 1080p HD video recording at 30 fps. The Raspberry Pi camera board features a 5 MP OmniVision 5647 sensor in a fixed focus module. The module attaches to Raspberry Pi, by way of a 15-pin ribbon cable to the dedicated 15-pin MIPI camera serial interface, CSI, which was designed especially for 1V software requirements. TensorFlow. TensorFlow is a machine learning software library that is both free and open source. It can be used for a multitude of activities, but it's best known for deep neural network training and inference. TensorFlow is a symbolic math library that uses data flow and distinguishable programming to solve problems. TensorFlow is a cross-platform programming language. It works on a wide range of systems, including GPUs and CPUs, as well as handheld and embedded platforms and even tensor processing units, TPUs. The TensorFlow distributed execution engine abstracts away the many compatible devices and provides the TensorFlow framework with a high-performance core written in C++. Keras. Keras is TensorFlow 2 is high-level API, a user-friendly, highly efficient platform for resolving machine learning problems with an emphasis on modern deep learning. It provides the necessary abstractions and basics for designing and shipping high iteration rate machine learning solutions. Engineers and developers can use keras to fully exploit TensorFlow's flexibility and trans capabilities. You can execute keras on TPUs or massive clusters of GPUs, and you can export keras models to execute in the browser or on portable devices. Layers and templates are keras' fundamental file formats. The sequential model, which is a linear stack of layers, is the most basic type model. You can use the interfacing to cameras. The CSI bus is capable of extremely high data rates, and it exclusively carries pixel data to the BCM2835 processor. The board itself is tiny, at around 25 mm x 20 mm x 9 mm, and weighs just over 3 grams, making it perfect for mobile or other applications where size and weight are important. The sensor itself has a native resolution of 5 megapixel, and has a fixed focus lens on board. In terms of still images, the camera is capable of 2592 x 1944 pixel static images. 3. LCD display. The 16x2 LCD packs 32 characters into an outline smaller than that of most two-line displays. And LED backlight enables optimal viewing in all lighting conditions. This unit uses the HD 44780 interface found on most parallel character displays. Keras operational API for more complex architectures, which allows you to construct arbitrary layer graphs or write models entirely from scratch through subclassing. For design and implementation. First, speaker's S video is captured using a camera. From the speaker's video, different frames, image, are obtained by stopping at single frequency. For example, a 1SEC video is converted into 30 frames/secretary from the set of frames. Face is localized in a video frame. Then localize the lip region as it increases the accuracy. OpenCV is used to localize the lip region. OpenCV is a computer vision library, has very little support regarding neural network/deep learning. It can provide only computer vision/image processing utilities to your program. Machine learning libraries like TensorFlow, scikit-learn, Caffe, etc. have to be used to implement systems like LipNet. In the lip geometry-based feature extraction, the region of interest is the lips. Accordingly, the mouth region's area is calculated. The height and width ratios of the mouth is used as features. These features are more applicable where the surrounding is more crowded area and contains lot of noise. Hence, in it only visual features are required. In appearance-based features, the tongue, teeth are considered for lip movement detection. Since the geometry-based features were having the drawbacks like detecting the mouth feature reliably, lighting conditions and many more, to overcome this appearance-based features are considered. It was an alternate way for the extraction of features using the pixel data as features. Improved local binary pattern, ILBP, from the three of the orthogonal planes was considered for change in the time and the space of mouth's region. The binary image of lip is also taken as the feature. This work is licensed under a Creative Commons Attribution 4.0 international license. Taken the mouth opening, which consisted of tongue and teeth as a feature, in which the teeth area was taken as the ROI and the contour of it was taken as the feature for further processes. The lips and mouth region are the visual parts of the human speech production system. These parts hold the most visual speech information, therefore it is imperative for any VSR system to detect/localize such regions to capture the related visual information, i.e. we cannot read lips without seeing them first. It is then compared with the lip dictionary, and if it is a match, text and voice are released as outputs.